Good morning to you. In continuation to the unit 1, the topic number 3 is characteristic strength, characteristic load and partial safety factors. We'll move to the characteristic strength. So, according to the definition, the term characteristic strength means that the value of strength of material below which not more than minimum acceptable percentage of test results are expected to fall. So this is what the definition of a characteristic, as we all know already. So in that, according to IS 456 2000, have accepted the minimum acceptable percentage as 5% for the reinforced concrete structures. So accordingly, so the design strength should be lower than the mean strength. So according to the strength point of view, as we have discussed in the limit state method, the strengths are underestimated. So likewise, the design strength should be lower than the mean strength. So when we calculate the characteristic strength, so that is nothing but it is mean strength minus k times the standard deviation, where k is a constant, so which is derived from the normal distribution curve according to the what we assume the acceptable percentage as 5%. No? For that, accordingly, the k can be derived. So in that, when we see the mathematical expression of a characteristic strength, that is Fk is equals to Fm minus k times the standard deviation, where Fk is what like characteristic strength of the material, and Fm is F suffix m is a mean strength, and k is a constant, and Sd is a standard deviation. So this is for different set of test results. So now we'll see the K value. It is given as 1.65. So accordingly, from the normal distribution curve, the characteristic strength can be found out by using this normal distribution curve. So this figure shows the frequency distribution curve of a strength material, that is for both concrete and steel. So the value of K corresponding to 5% area of the curve is 1.65. As we can see that 5% results are not expected to fall. So that is what this is accordingly this. So the Fk is the K is taken as 1.65. That is mean strength minus 1.65 times the standard deviation. Now we'll see that exactly the characteristic strength of concrete. Accordingly, when we apply to the concrete and steel, so it is denoted by FCK, F suffix CK, so which is expressed in terms of Newton per mm square. And this characteristic strength of concrete value is different for different grades of concrete. So, such as that is we are having different grades of concrete such as M15, M20, M25, M30, like that, so on. Different grades of concrete. Accordingly, the characteristic strength of concrete can be calculated. So in that M15, or when you take particularly M25, so in that where M is what the mixed design. So that is what we have seen in the concrete technology, the design mix of concrete, where M refers to the mixed design, and this number 25 refers to the characteristic compressive strength of 150 standard cube size cured at 28 days, and which is expressed in terms of the Newton per mm square. So this is what the definition of a characteristic strength of concrete. So similarly, the characteristic strength of steel, this value shall be assumed as the minimum yield stress, or 0.2% of the proof stress specified in the relevant Indian standard specifications. So this is what we have seen in the stress strain curve for mild steel there. The characteristic strength is nothing but what we have to take is either the minimum yield stress for mild steel, or for other grades like Fe415 or HYSD bars. For that, 0.2% of the proof stress is taken as the characteristic strength of a steel, and which is designated by the symbol called Fy. And this is also expressed in terms of the Newton per mm square. So these two are about the characteristic strength of steel and concrete. Now, when particularly when assessing the strength of a structure or a structural member, for the limit state of collapse to be considered, the values of partial safety factor, that is gamma, should be taken as 1.15 for steel and 1.5 for concrete. So these are all the partial safety factors to be considered for the characteristic strength of concrete and steel according to the IS 456 2000 provisions. Now we'll see about the characteristic load. So as you seen in the characteristic strength, similarly the characteristic load. The term characteristic load means that the values of load which has a 95% probability of not being exceeded during the during that entire life of the structure. So this is what the definition of a characteristic load. Here, the 95 percentage should not be not being exceeded. So accordingly, the this characteristic load can be calculated as mean load plus k times the standard deviation. Whereas in the characteristic strength, mean strength minus k times the standard deviation we are done actually. But here, since the loads are underestimated, so for that, so the mean load plus k times the standard deviation has to be taken. So here same thing, Fk is what the characteristic load and Fm is mean load, and where k is a constant, which is same again following the normal distribution curve of 5% of the for the 5% of the results, which is 1.65, and SD is a standard deviation of the load. So finally, the design load is calculated by multiplying the characteristic load into partial safety factor. So where FD is a design load and FK is a characteristic load obtained from this, and where gamma is the partial safety factor for the load. Again, partial safety factor for the load is considered from the IS 456. There is one table given in IS 456. This is what the table to be referred to multiply to consider the factor of safety for the loads. So accordingly, say for example, we'll consider one example. If the load is considered in combination with dead load and live load, correspondingly, if you are doing with the limit state of collapse, so these are the factor of safety to be considered for the limit state of collapse. And for if you are doing for the limit state of serviceability, which means that if you are checking any deflection or cracking, in that case you need to consider the partial safety factors are as for the dead load and live load, it is 1 and 1. So similarly, for different load combinations, the corresponding factor of safety are considered for the calculation of the design load. So this is about the characteristic load, characteristic strength, and partial safety factor to be considered in a structural analysis. Considered in the design of the RC structures. Thank you.